Okay, so for this video, we're going to go through and review and add some new things to electrical activity of the heart. Now, if you remember from previous classes, exercise physiology, human structure, some of you, advanced anatomy physiology for the rest of you, or even biology, uh, the heart is a muscle, cardiac muscle, and because of that, when it contracts, it depolarizes. But just like other muscle, it has nerves, as neurons traveling to it. Now, what makes heart unique is that it actually has its own unique conduction system, because one of the keys in heart muscle is we need the heart, every cell in the heart, to contract at a very, very specific time. We don't need what we see in skeletal muscle. Now, if you remember skeletal muscle, we talked about previously that there's motor units, and depending on the activity, some motor units are used, but some aren't. Well, when the heart contracts, we really need every muscle cell to contract. We don't need just some of them to contract. I mean, the heart's got to push blood through the rest of the body. It has to produce a lot of pressure, a lot of stroke volume. And because of that, we need every muscle cell in the heart to contract. Well, in order to do that, we need a little bit different system. And so the system of conduction in the heart looks like this. And there's some animations on canvas you can take a look at that go a little bit more in depthly through this, but I'm just going to walk through this quickly step by step, and then we're going to talk about what happens when this messes up, because it does mess up. So we're going to start here in what's called the SA node. Consider this just a piece of kind of nervous system tissue. We call it the pacemaker, and this is where every heartbeat, everything in conduction is going to originate from. Now, it's not actually green here, by the way. It looks just like other tissues in the body. And what will occur is this SA node will depolarize. Now, you probably remember depolarization from different classes before, biology or human structure and function with me. So the SA node depolarizes, and when that depolarizes, the cells around it depolarize. Now, again, what makes cardiac muscle also unique is cardiac muscle cells are surrounded by what are called intercalated discs. And these pieces of tissue allow conduction to go from one cell to another very, very quickly. We don't really see this in skeletal muscle or smooth muscle, but we do in cardiac muscle. And because of that, we literally start to see all these cells around the SA node depolarize. And then when they depolarize, cells around them depolarize. And when they depolarize, cells around, you kind of get the idea. And so what begins to occur is we start to see this wave, literally this wave of depolarization through the atria. Okay, so that's just the atria. Notice I said the atria, not the ventricles. So at that point, then we have depolarized all the muscle cells in the atria, and then we get to the AV node. Now, the AV node, I often say, is kind of like the blinking light in a small town. It doesn't really stop anything, but it makes you slow down. That's kind of what the AV node does. The AV node is going to slow down this pace of depolarization, so there's a slight pause. Now, the reason for this becomes obvious if you understand anatomy. When the atria depolarize, they are going to push blood through the tricuspid and through the mitral valve into the ventricles. Now, it's preferable, however, to give these ventricles just a little bit of time to fill before they contract. And so that's what the AV node allows us to occur. It's going to pause this depolarization so the atria can contract a couple, 0.1, 0.15, 0.2 seconds. Then the ventricles can contract. Just enough time for the ventricles to fill with blood and then push that blood out. So we see this paused AV node. Then we're going to see this depolarization move down the ventricles, left side, right side, and the cells in the ventricles are going to depolarize. Now, what makes these unique is that you'll probably notice the ventricles are really, really big. A lot of muscle. I mean, you can just tell. Look at this size. That's a nice, meaty little muscle there. Very different than what we see in the walls of the atria. Well, because of that, there are a lot more cells in the ventricles. If we relied on this same system of going cell by cell by cell, waiting for these cells to depolarize, depolarization of the ventricles would take way too long. It quite literally would be, instead of a nice contraction, it would take quite a long time. Not enough time for us to be able to push adequate stroke volume and then cardiac output to the body. Well, because of that, we have what I like to call some freeways or some branches of nervous tissue. They're called the bundle branches that allow this conduction to move to other aspects of the ventricles very quickly. This is kind of like taking the turnpike home on break. There's small roads you can take, but let's be honest, we all want to go faster and get there quicker. That's what the bundle branches allow to happen. And then that will allow the ventricles to depolarize. Now, we can see this on an EKG. And on an EKG, what we see here, this is resting EKG. We have a P wave. And so think of the events here. We're going to have the atria, watch my cursor, the atrial depolarize. So SA node fires, atria depolarize. Then there's a pause, AV node, now it goes past AV node, ventricles, boom, 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 like that. That's ventricular depolarization. And then we're going to see this T wave. Now this T wave, if you remember with cell membranes, and when they depolarize, at some point they have to repolarize. Well, the T wave, this is repolarization, but specifically it's ventricular repolarization. Now you may ask, hey, Dr. Mitchell, great, but okay, so if the ventricles depolarize, what happened to the atria? Didn't they repolarize? Well, yes, they did. But if you look at the timing, the atria repolarized right around here. Well, because the ventricles are depolarizing, we don't see it, but it is there. So think of this as atrial depolarization, ventricular depolarization, and then ventricular repolarization. All right, so that's the basic EKG. Again, that's a review for some of you. In the next video, I'm going to go through some arrhythmias and look at, okay, so what happens when this whole thing goes wrong? So that'll be the next video.